Hey folks, we're on to chapter 6 here. Again, we're skipping over chapter 5. It's got a lot more advanced data modeling stuff in it. Nothing we need at this point in time. That's something you can revisit if you want to continue to move on further with database technologies. But for us, the entity relationship diagram should suffice for everything that we need to do to be able to get that idea of a database down from just here's some ideas to a conceptual diagram to the actual implementation logical diagram that we need. So with chapter 6, we're going to look at, once we have that done, now we need to do a little bit more work, and this is called normalization. It's a big fancy term, but the idea is that we want to look at all of our tables, all the structures, all the data that we have, and we want to further reduce redundancies. Remember, because every time we have redundant data, if the data here is redundant, it's going to increase the chance, means more chance, right, a greater percentage of errors. And errors mean money, either lost money or just the lost potential of money or just screwing something up, having to repeat it again here. So the less redundancies, the better. And this normalization process is all about how we make sure we are optimizing our storage to not completely eliminate redundancy, but to control redundancy. Again, when we have that foreign key in a table, it is redundant data, but it's like the minimal amount of redundant data that we need. So this normalization process has a bunch of fancy terms here. We're going to get through most of the fancy terms. So we're going to talk about first normal form. We're going to talk about second normal form. We'll talk about third normal form, and this one gets the big star here. That's not how you draw a star. Sorry. That one gets a big star because this is the most common. This is the goal for most of the time what we want to do here. Now there's also this silly Boyce Codd normal form. We don't really care about that one very much. And there's fourth normal form that, again, we most of the time don't really care about. There are even higher ones. You can go further here, and again, we don't really care. For our purposes, for what we might say is an ideal implementation, is we're aiming for this third normal form. And there's a process we're going to go through, we'll get into. And now, just because it's the ideal from, hey, we want to design an optimal database, doesn't always mean that this is what we're actually going to be doing. So we might end up in a different space or a different place based on some performance requirements. So this is the process of normalizing, right? Normalizing our data to go this direction. So we're reducing the redundancy, having controlled redundancy in our data, but there's also a process of denormalization. There's an R in there. Denormalization. And that is essentially going the other direction. It's increasing redundancy. So we're going to increase redundancy. But we're going to do it in a controlled manner. And we're going to do it essentially for performance purposes. So if we have specific performance requirements, we might look at this denormalization process. But again, aiming for this third normal form is kind of our ideal spot there. And again, why we want to do this is we want to reduce the amount of redundancy that we have to reduce errors in our data, because errors cost us money, essentially. They cost the business money. So, right, when we went through designing our database, we talked about our business rules, we talked about identifying the data and the constraints for it, any sort of functional dependencies on our data. We talked about identifying the entities and relationships, and then we looked at eliminating those multi-valued attributes. Right? The multi-valued attributes was, hey, I have one particular column here, and this might be like your certs. I can't put all of your certifications in a single column. That's a multi-valued attribute. This is essentially bad here. So kind of look for anything with an S, anything that's plural, there's a chance it might be a multi-valued attribute here. So we can't have a certs field in an employee table, right? We might have our employee table, and we might have all of our other employee ID and name and salary and all sorts of that good stuff here. But we can't have a bunch of certs here. We can't list out, hey, you're a PMP, you're an A+, you've got the Network Plus, right? This is no good. We can't have that multi-valued field. So if many employees have many certificates, and many certificates are held by many employees, we really have this CERT, certs. We've got a many-to-many relationship. And this is fine at a conceptual level, right? So employees can have many certificates held by employees, but we know, and based on what we did last week for our discussions and some more of this practice, is we need a joining table, right? So we'll have the certification. That way we only have it one time, and we're not going to say, okay, well, this one was a network plus and this one was a net plus. And when you want to go look up, hey, who has a network plus certification, you're going to miss the one that was spelled net plus. Right? Again, we want to make sure that we don't run into problems like that with data entry. So we want a single table of all these certificates, right? Here's your PMP, here's your A+, here's your Network Plus, here's your Microsoft Certified Systems Developer or something like that. I forget. There's a bunch of them. And, any list of certs here. Fine. Great. That's our certs. Then our joining table will solve this many-to-many relationship. We'll say, okay, one employee, this is, again, cert is kind of a funny name. It's not certification because this is our certification table, right? And it shouldn't be certification. Right, so what an employee has, this might be, I don't know, earned certifications or something like that. You can come up with some sort of good name for it here. And then we would have the employee ID as a foreign key as one of these fields, and then you would have the certificate ID as the other field. Right? The certificate ID as the other field. This is not wanting to scroll for me right now. Certificate ID as another field, and then we can additionally, what other data might we want to know? Maybe we want to know when you got the certification, so we could then, with this joining table, add additional information like the date. When was it? Right? Does it expire? Maybe we have an expiration date here. Any sort of thing we want to put in here in this joining table, any sort of attribute that would give us more information about that relationship is great. And then we turn a many-to-many into, again, these are probably optional, right? Employees don't have to have certifications, and a certification on our list, it doesn't have to be had by an employee, right? Maybe we add a brand new certificate and we just don't know who has it yet. So that, again, that optional notation, right, for their participation. So we're going to take that joining table and we're going to add it here so that we don't have that multi-valued attribute. Multi-valued attributes are bad and we don't like them. And we run into all sorts of problems with them here. Essentially, we'd say it's unnormalized data when we're just looking at this. Hey, this is a spreadsheet I have. Essentially, it's unnormalized. We're going to go through the process of trying to fit it into tables.